In this episode, we're going to create an internal application load balancer. This load balancer will distribute incoming traffic to two EC2 instances that are running a web API. Each EC2 instance is placed in a different private subnet and in a different availability zone within the same region. This design improves high availability, meaning if one availability zone experiences a problem or goes down, the other can still handle the traffic and keep the web API up and running. I recommend reviewing the official Elastic load balancing documentation and pricing. Now let's open the AWS Management Console and search for target groups. Click on this link. Click Create Target Group. Choose Instances as the target type. Enter a target group name. Select HTTP as the protocol and enter 80 as the port. Choose IPv4 as the IP address type. Select the VPC we created in one of the earlier episodes. Choose HTTP 1 as the protocol version. Select HTTP as the health check protocol and enter a health check path. Click Next. We will choose the two EC2 instances we launched in a previous episode in private subnets. Enter ports for the selected instances. Click Include as pending below. Click Create Target Group. We will create the security group for the internal application load balancer. Enter a security group name and description. Select the VPC we created in one of the earlier episodes. In the Inbound Rules section, click Add Rule. Select HTTP as the type. Enter the private IP address of the EC2 instance we launched in the public temporary subnet as the source. In the Outbound Rules section, select Custom TCP as the type. Enter the port range. Select the security group associated with the EC2 instances that we launched in the private subnets as the destination. Then click Create Security Group. Click Load Balances. Click Create Load Balancer. Click Create Application Load Balancer. Enter a load balancer name. Choose internal as the scheme. Choose IPv4 as the load balancer IP address type. Select the VPC we created in one of the earlier episodes. Choose the availability zones where we created private subnets. Select this private subnet and select this private subnet. Select the security group we created for the load balancer. In the listener section, select HTTP as the protocol and enter port 80. Select the target group we created as the default action. Click Apply Application Layer Security Protections. Choose Auto Create Predefined WAF. Select Block as the rule action. Choose Auto Generated as the resource name. Then click Create Load Balancer. If the load balancer is in the active state, click Network Interfaces. Here you will find the IP addresses for the EC2 instances and load balancer nodes we launched. Search for ELB. Here you will find the private IP addresses for the load balancer nodes, which often change. Search for the WAF. Click on this link. Click on Web ACLs. Here you will see the Web ACL that was created when we launched the internal application load balancer. Click on the Web ACL to view more details. Here you can add, delete, or edit rules. I recommend reviewing the official AWS WAF documentation for further details. I will show you how I modified the security groups and network ACLs required to successfully send HTTP requests to the internal application load balancer. There are the two security groups associated with the EC2 instance in the public temporary subnet. Additionally, we have two EC2 instances in different private subnets. Here is the security group associated with both EC2 instances. This security group is associated with the internal application load balancer. In the inbound rules, it accepts HTTP requests from the EC2 instance we launched in previous episode using this private IP address. In the outbound rules, it allows the internal application load balancer to send HTTP requests to the ASP.NET Core Web API, which works on port 57171 on the two EC2 instances in the private subnets associated with this security group. This security group does not have inbound rules, but it has outbound rules. In the outbound rules, we allow the EC2 instance in the public subnet to send requests to the internal application load balancer. This security group allows connections to the EC2 instance in the temporary public subnet via the EC2 instance connect option and does not have outbound rules, only inbound rules. This security group is associated with the two EC2 instances launched in the private subnets. It only has inbound rules, not outbound rules. In the inbound rules, it allows requests sent by the internal application load balancer to the ASP.NET Core Web API running on port 57171. The network ACL associated with the private subnet in the US East 1 C availability zone, where the EC2 instance is launched, allows the EC2 instance launched in the temporary public subnet to send HTTP requests to the internal application load balancer. It also supports cross-zone load balancing. The network ACL associated with the private subnet in the US East 1B availability zone, where another EC2 instance is launched, also allows the EC2 instance in the temporary public subnet to send HTTP requests to the internal application load balancer, supporting cross-zone load balancing. The network ACL associated with the public temporary subnet in the US East 1B availability zone, where the EC2 instance is launched, allows the EC2 instance to connect to the EC2 instance in the temporary public subnet and send HTTP requests to the internal application load balancer. If target group is healthy, we can proceed by sending HTTP requests to the internal application load balancer from the EC2 instance in the public subnet. Copy the DNS name of the internal application load balancer. Next, we will send an HTTP request to our ASP.NET Core Web API. In the HTTP header x forwarded 4, we can see the IP address of the client that sent the request. This IP address is the private IP address of the internal application load balancer node. Next, we will send an HTTP request with the x forwarded 4 header set by the client. The client's IP address appears after the last comma in the x forwarded 4 header. Go to the load balancer section. Select the internal application load balancer and click Attributes, then click Edit. Here you can see that the Append option is selected for the X forwarded for HTTP header. I personally recommend keeping the Append option selected for this header. If needed, we can enable client port preservation to view the source port the client used to connect to the load balancer in the request. Click Save Changes. Here we can see client IP address and port. Now we will terminate the EC2 instance in the temporary public subnet and delete both the temporary public subnet and the internet gateway from our VPC. Now we will block public access to our VPC. Click on VPC. Click on Block Public Access. Click Edit Public Access Settings. Check Turn on Block Public Access. Then click Save Changes. In the next episode, we will connect the internal application load balancer to the Amazon Gateway HTTP API.